Welcome, everybody. Sorry, Bill and I were just talking about Kepler. We do sometimes. My name is Dan. I'm the director of the Rotman Institute of Philosophy. I'm very grateful that you've all come to join us tonight. I'd like to start just with a few brief notes. First, to acknowledge that we are on the traditional territories of the Anishinaabe, Haudenosaunee, Lenape-Wauk, and Chinongtan nations here. And I'm really happy to be here with my astronomer colleagues and philosopher colleagues. One of the things that I learned from my astronomer colleagues is that, a lot of different disciplines have come to engage in a more fulsome way with Indigenous sovereignty. And you might not think astronomy would be at the top of the list, but it is, because so many of the most important ground-based observation stations on the Earth are also incredibly important sites for Indigenous people, and astronomy as a field has really had to reckon with their relationship to indigeneity and sovereignty in that way. And so one of the things that we do as academics is think about how we can engage, and I think an important thing is for us to learn from each other, and so that when I get a chance to let folks know that the astronomers are part of this conversation and they've learned a lot, I'd like to share that. So that's just something I wanted to tell you about. Tonight, we've got a crack team of researchers who are pursuing a really fascinating project at Rotman that bridges the gap between astronomy and philosophy and law and many other disciplines, and that's really what the Institute is about. We are an Institute of Philosophy, but we are an Institute of interdisciplinarity and openness and bringing people together. And so I'm going to let them introduce themselves, but please give a warm welcome to our panel and look forward to hearing about their...
Good evening, everybody. My name is Pauline Barmby. I'm a professor in the Department of Physics and Astronomy, and I'm also a member of the Rotman Institute for Philosophy. And I am here to kind of kick us off. As you can see, I have my mask on, and I hope I don't have to talk for too long. But this works out because I wasn't planning to talk for very long. I'm just going to set the stage for this project and then have our PhD student researchers tell you most about what we did. So 6 months ago or so, the Rotman Institute put out a call for think tank proposals, where you would get a bunch of people together and think about something that they hadn't thought about before. And I was casting about for, well, what do I want to think about? And satellite constellations came up as a topic of sort of a specific topic as part of, well, is there a philosophy of space? And it turns out that there is. But satellite constellations are a particular part of that I was really interested in exploring further. And so let me tell you a little bit about what satellite constellations are and why you might care about them. And then I'll tell you a little bit about our particular research project, and then I'll let our researchers tell you a bunch of the details. And then we'll have a little panel discussion between the researchers and then time for you to ask us questions after that. So, satellite constellations. This plot here on your left shows the cumulative number of objects that have been launched into space by humans from the surface of the Earth, starting from the first satellite launch in 1957 and going all the way up to the end of 2024. And you don't need to see the exact details of which country is what here, but the important idea is that you can see this very rapid turn up just a couple of years ago. And that very rapid turn up really happened in about 2019, 2020. And that's when a number of companies started launching what they call satellite constellations. So these are groups of satellites, nearly identical usually, so mass-produced satellites, not things like the Hubble Space Telescope, which are one of a kind, or the early satellites, which were one of a kind, but hundreds or thousands of nearly identical satellites, typically for the purposes of things like providing satellite internet or Earth observation or other things that you can do from space. And they're called constellations not because they make a pattern in the sky like Orion or the Big Dipper or something, but just because that's a nice word for a bunch of stuff in space. So satellite constellations, sometimes called satellite mega constellations for the really biggest ones. So a number of companies have launched a whole bunch of these things. You can find them in all kinds of different orbits around the Earth, but this visualization kind of shows you the scale is correct here in that these things are sort of filling up right around low Earth orbit, close to the Earth. And why would we care about them? Aren't these good things? Aren't we happy about them? You know, if you live in a remote place and you want satellite internet, you probably are happy about them. If you are an astronomer trying to make observations from the surface of the Earth, you might be less happy about them because these things move quickly across the sky. They can leave big streaks across your images. And there's also reason to be concerned about other things, like what if they run into each other? And then you have a bunch of little pieces in space, which is also not so good. And so astronomers have been concerned about satellite constellations for a while, and other groups are sort of also starting to think about them. And so what we did in this research project was try to get a handle on the bigger picture of satellite constellations. So we wanted to know who is thinking about them, who are the stakeholders in these questions. It's not just astronomers, it's not just the people who build and launch the satellites, but lots of different groups. And so what do they think about the issues raised by satellite constellations? What kind of laws are involved in thinking about satellites? Who determines who gets to launch satellites? What happens if my satellite hits your satellite? That kind of thing. And then how can we actually measure the problem? So astronomers say bad, but how bad? How often? All that kind of thing. And so I recruited a couple of professors to work on this work. That's the people at the bottom of the list there. Professor Oosterveld is here with us tonight. But of course, the people who did the actual work are 3 PhD student researchers who are going to now tell us what they learned. And we'll start with Sarah. So there you go.
Okay. Hi, everyone. So my name is Sarah. I'm a PhD student in the Department of Philosophy. I'm also part of the Rotman Institute. I was in charge of something called controversy mapping. So before we delve into all of this, I'm just going to give a quick, what is it? What are we doing? Controversy mapping was or is a tool designed by Venturini and Munch in the late 1900s. Basically, what they thought was, we're having so many developments in science that do not only correspond to scientific values, that do not only correspond to scientific stakeholders, that they're actually affecting other groups, and therefore other groups have a saying in how those scientific things are becoming to be. So, for example, for satellite constellations, this is particularly important because it's not necessarily only scientists, the ones who are shooting the satellites up into space. It's mostly companies and private people just wanting to learn or sell a product. But they're also affecting other communities, as I might explain. So what they designed is, okay, we want to be able to see what is it that people in general, and who is talking about this first, and second, what are they saying? What are the different positions? What is it that is being discussed in this arena? So knowing this, I found 4 different things that people are talking when they talk about satellite constellations. The first thing that people are interested on is space debris. This devolves into 3 different controversies that people are describing. The first is responsibility. Who is responsible for example, cleaning up there? Who is responsible for making the satellites go down again? Who is responsible for taking care of that space? Or is it the case that once you put it up there, it's free for all? Second, knowing exactly how many things are up there. just as Pauline was mentioning, when two satellites collide, for example, they leave a bunch of other little pieces. And the thing is, because of the velocity that they acquire, even the tiniest little piece can affect other things. So it's not really that we need to know, oh yeah, I shoot one satellite, therefore there's one thing. No, there can be 1,000 if one of them collide. And what are the different environmental risks of trying to deorbit? The second big thing are the climate change concerns. So one might think, for example, oh, there's two sides to this. The first one is shooting things up there actually interacts with several layers of the Earth, which affects the air quality and therefore many other chemical processes that happen in the environment. And this affects, consequentially, climate change. But also, this is the best tool to analyze images and to analyze data from a general perspective. That's not only the specific ecosystems. So how do we balance out these two things? Needing the data versus not wanting to affect climate change while getting the data. The third main controversy that I found is the socioeconomic concerns. So who is shooting up those satellites? How come the things that they manage to provide, so for example, Wi-Fi or cellular data, create or manufacture a bigger gap in the digital, like called the digital gap? If this empowers or creates more power inequality, not only through the access of physical space, which I'm not gonna get really into because you're gonna learn a little bit more about that, and the next person will be talking about that, but also who gets to enjoy the products of that constellation of satellites. And finally, what happens with the way that we interact directly with the night sky, which is mostly around pollution, not necessarily direct pollution, so not necessarily that all of us, we're going to start seeing a lot of satellites, although it is possible to see them and that affects it, but also how much that affects the way that people are interacting with certain spaces that were not accessible before. But because now we have internet and cellular connection, now they're getting more and more accessible. And if we start interrupting those spaces, how are we going to start developing a new relationship with the sky and spaces here? So how does that affect, as Dan mentioned in his presentation, the way that, for example, indigenous astronomers interact with the sky? How is that going to affect the way that we interact with the sky? All of these different things come together, not in we all should use it for good or should use it for bad, but it's all very contended. And so my general report was a description of what is being said, who is talking about these things, what are they saying, where are they coming from, and what are their purposes, and what is it that they want to defend. So that is the first part of this project, and I will leave it to the second part.
Okay, hi everyone. My name is Ghazal Andanif, and I'm a third-year PhD student. I work with Professor Oosterveld. So now we're talking about the legal study aspect of this project. And for that, first of all, I want to talk about the legal frameworks, talking about which are related to a mega constellation of satellites. Then I will talk about the gaps and then legal guidances. So the Outer Space Treaty, International Telecommunication Union regulations and treaties, and space debris mitigation guidelines are international legal frameworks which are related to our topic. And then nationally, we have Canada's Remote Sensing Space System Act and regulations. But all of these frameworks are general and they have some gaps. For example, the first question is, are these megaconstellations actually a form of orbital appropriation? Or, for example, authorization and supervision of satellite constellations by national authorities is not enough. So the question is that is an international cooperation is needed, a kind of mechanism is needed or not? And what does paying due regard to the corresponding interest of all other state parties to the treaty require when a country is considering authorizing satellite constellations? So if we want to talk about the legal gaps, the first important gap is lack of binding international regulations which could govern design, deployment, and operation of satellites. The other important gap here is the absence of independent mechanisms, international kind of mechanisms, which could be used for dispute settlements. And then absence of international regime, which is focused on the management of orbit pollution and space debris. And then one of the important gaps are regarding the safeguard to prevent de facto monopolization of orbital slots. The other one is regarding the ITU, the International Telecommunication Union, assigns of orbital slots and radio frequencies, which is not clear whether it's function as a good thing for example, the astronomical activities or not. And then last but not least, spacefaring nations apply their own national laws, national safety and environmental regulations to satellites, and it's oftentimes not in compliance with international regulations. So what I did was to figure out what could be the legal solutions. There are two parts of solutions, one ideal solutions and one more realistic kind of solutions. The ideal solution, the first ideal solution is a multilateral binding agreement, which could establish clear standards for and the scope and limits of mega-constellation of satellites. But the more likely kind of document could be guidelines like the space debris mitigation guidelines, which is of course not binding. The second ideal solution could be establishment of a standardized dispute settlement mechanisms, which obligates states to address matters of responsibility and liability. But the more realistic kind of solution would be arbitration mechanisms. The other ideal solution would be harmonizing national rules and policies on environmental issues related to mega constellations, but the more realistic solution would be harmonization to a lesser degree through guidelines again. And lastly, regarding Canada, Canada adopts comprehensive space-related legislation that updates and streamlines regulations of satellites, applying environmentally and culturally sensitive assessments and continued kind of reporting and monitoring. So this could be the ideal solution. But what could happen in practice is the adoption of a series of pieces of space-related kind of legislations, which could be with narrower focused on environmental or cultural assessments. So that was the legal part of this project. Thank you.
So hello everyone, my name's Jack, and I have a very static way of walking apparently. So I'm also a PhD student in philosophy, and I work on philosophy of physics. I'm in my 4th year, so you can see how that ties in to this. So we've heard about kind of the broad issues surrounding mega constellations in the abstract of various different separate questions you could have about their negative effect on things, or negative or positive. So the purpose of my part in all of this was to focus in a very specific part of that question. So everything related to what happens when you look up at the sky, and what will you see when you look up at the sky, right? So principally this relates to astronomical observations, if you're trying to kind of work certain things out by doing photography of the sky, or if you're just, for leisure looking at the sky, right? So, those two things sound like they're quite far apart, but the actual data you need to quantify the effect on either is very similar. So how do we do this? So we basically had a big set of data collected from these contraptions on the top left here. So these are essentially just night vision security cameras pointed at the sky. And so they collected a big load of data over about a month and a half of just every time they saw something that looked like a satellite go across, they would record that, they would log it, and they would work out what satellite it was. As in, they would just give you a kind of a serial number for it. So my task was to take that raw data and to extract from that some kind of quantification of, what you see when you look up, right? Or what a telescope will see when it looks up, and how that is affected by these satellites. So, this is the key finding here, right? That went in the paper that resulted from this, which is, this is a plot of all the sightings that were spotted using this system. So on the vertical, you've got magnitude, it's inverted, so basically higher is brighter, right? And you have the altitude of the object that was spotted. And what this line here represents is the kind of international recommendation of how bright a satellite should be when it appears in the sky. And this is basically, 7 is about what you can see with the naked eye, right? So what this is based on is the idea that you don't really want these things to be visible to the naked eye, if you can help it. And then this line goes down. I won't linger too much on this, but this is because higher altitude satellites move more slowly across the sky. So they will actually look brighter on a camera because they linger in each pixel for longer. So the higher satellites that move more slowly, you actually want them to be less bright, which is somewhat counterintuitive. You might think if they were slower, they would be less of a problem, but they're more of a problem. So you can see here that, about half the results are above this line, right? So if all you did was just look at this picture, this would kind of, in a way, answer your questions about what's the kind of visual effect of these satellites straight away. Over half of these results in general are in this kind of too bright region relative to this international recommendation. And then just the color coding just gives you some of the principal constellations here that I'll move on to in a second. You can see though that Starlink, which is unsurprising, is by far the most frequently observed one, and it has about half of its results above that. So if we delete everything below this line, just keep that and put it into a bar graph, this is what you get. So the orange is just the total number of observations, and the kind of light blue is what percentage of the observations overall were above that line, right? Because you could see they kind of spanned it, or they spanned the line. So Starlink just dwarfs everything else. You have rocket bodies. So this is like every rocket body ever launched, right? And then Starlink is like 4 times bigger than that. So Starlink is an absolutely enormous contributor to this. And everything else kind of is barely visible by comparison. So no surprises that the most dominant impact is coming from Starlink. But one of the more interesting things is when you look at this relative measure, Starlink is not actually the worst offender. There are various other constellations that, even though there are fewer satellites, their satellites were too bright a larger proportion of the time. So that gives you some indication of the general intrinsic brightness of different kinds of satellites. And one of the patterns here was a lot of the early stage Chinese constellations that are kind of still in the development phase were substantially brighter than various other constellations. So that's concerning, right? Because there are plans for these constellations to end up expanding to a level where they do end up rivaling Starlink like mega constellations. So if they remained kind of having this intrinsic brightness while scaling up, you'd have an even bigger problem than Starlink currently is. And the key one to look at here is OneWeb, right? So I don't know how many of you will have heard of OneWeb. In many ways, it's just a kind of generic telecoms constellation, but they've managed to get it so that they're very, very dim compared to the other satellites. So this is, again, another key thing to take away, right, is that it is possible to get these satellites to be quite dim, such that they barely turn up, but it's not incentivized, and this is why you don't tend to see that very frequently. And I'll just whiz through this last bit. So this is, the previous stuff was about kind of different types of constellations and what the differences in brightness between them are. This quantifies something different. This is about the effect that a given constellation, or, you know, if you add up all the constellations, the effect it will have at different times and places on Earth. So this is day of the year, this is latitude. And so what this basically represents, so you can find, you know, London, Ontario up here at about 43 degrees latitude. And so yellow just means that the entire night is going to have satellites visible in quite a high intensity to you. So there are times of the year at high latitudes like where we are now, where in the summer, even though it's night and it's dark, you will see satellites the entire night because the sun is quite low, but quite shallow below the horizon. So this is a bigger issue at higher latitudes because the sun in the summer doesn't get as low below the horizon. Whereas if you're close to the equator, you actually, while you do still have satellites turning up, you know, between 2 hours after sunset and before sunrise, there's a big stretch in the middle of the night where you won't see any satellites because you're entirely in Earth's shadow at that point. So, you know, it's a little bit technical, but the key thing here is that this is not going to be a uniform effect over the entire Earth and nor over the entire year. And even in a particular day of the year and location on Earth, within the night you have variations in how bad an effect this is. So, like I say, just close to sunset and close to sunrise is the most intense period. And so we worked out that during those periods, with a kind of fairly wide lens, about 1 in 10 images of the sky is likely to have a bright satellite streaking across it, right? So if you're trying to kind of detect something very sensitive with very sensitive equipment, that is going to mess with you about 10% of the time. Okay, I've probably gone on for too long already, so thank you very much.
The theme of this lecture series was research and its contribution to the public good. And so I thought I would start off our discussion by asking our panelists to tell us what they think about how access to space might be considered a public good. I don't know if you decided who wanted to go first. Anyone want to volunteer?
I can.
Okay, Jack, take it away.
Yeah, so I mean, the key thing that I think about space and the service it provides is currently, and this may change in the future, but currently the main service space provides is as a conduit of information. Right. So most of the services that we use space for are about information in one way or another. So either communication of information or gaining information about Earth or gaining information about distant places far away from Earth. So when it comes to considering public goods relating to that, what you're usually considering is some kind of payoff decision about what kinds of information you value relative to other kinds. So what we saw in these graphs, right, is one particular kind of information becoming dominant in these calculations, which is telecommunications, right? Space is being increasingly used overwhelmingly for telecommunications, and that is potentially going to come at the cost of other kinds of information about Earth, weather, climate change, and about distant planets. But I won't steal any more time.
Sarah, what would you like to add?
Yeah, I agree with what Jack just said, but I also think that I interpret the question a little bit different. I thought about it more as like space in itself as a public good and how connecting to it directly, how that could have affected the way that we relate to other things. So I was thinking that, yeah, internet and other telecommunications is clearly being prioritized over other things, but over things, for example, the way that we connect to the environment and the way that we connect to the sky and the way that we connect to our history through the sky and how we interpret cultural perspectives due to how we interact with the things around us. And I think that might also come into play when we're talking about if space is in itself a public good, in the sense that it brings up a specific type of culture that we should be enhancing or that we should be prioritizing over others. Yeah.
Thanks. So,
Yes. So in international law as well, legally speaking, actually, space is considered a public good, and this is because appropriation of space is not allowed according to different rules of international law. For example, the first article of the Outer Space Treaty implies in different ways that space is considered a public good. So I can read from some parts of Article 1. It says, for example, the exploration and use of outer space shall be carried out for the benefit and in the interest of all countries, irrespective of their degree of economic or scientific development, shall be the province of all mankind. Again, it says, shall be free for exploration and use by all states without discrimination of any kind. And lastly, it says there shall be free access to all areas of celestial bodies. So, legally speaking, it has been implied that space is considered a public good.
very good. Thank you. Do you want to add anything to the space as a public good?
Sure. I will just add that I think that lately, in the last while, space is also being put forward as a problem solver. And it may not necessarily be the problem solver that some claim it is. So for example, in discussing space mining, there are many saying, okay, we need to go into space and we need to get resources from Mars, from the moon, or from asteroids so that we can use them either in space or back on Earth so that we can decarbonize. But the efforts to do that will add so much carbon into the environment that there's a question there. And even the other day, like 2 days ago on the radio, there was a discussion about putting the data centers, the AI data centers that need a lot of cooling in space because space is cold. And that raises another question about whether does that actually solve the problem that we are facing about data centers using too much in terms of our environment.
Right. So that actually leads super well into my next question. Thank you very much. Which is that I want to think about something that we often get asked in astronomy is, what good is all this space exploration stuff anyway, right? Shouldn't we keep the money here on Earth? To which we typically point out, well, actually, the money does get spent here on Earth. We don't actually fire rockets full of loonies into space. But how do you think that research that's done in space or about space contributes to the public good? So not space itself, but the use of space and the use of research in particular. Does anybody want to tackle that one first?
No.
I can do it.
You're going to go in the same order? Okay, that's fine.
I don't know how. Yeah, I mean, there's various things one could say, right, but I'm going to pick the hardest one, which is defending these kinds of big question astronomical things, right? And I don't think the question should not be what is, to what extent is looking for black holes, for example, in the public good, but rather to what extent is kind of allowing an environment where people are free to do so in the public good? Is it to what extent should we be permitting those who have interest in certain kinds of deep questions to pursue those questions without being impeded by others, right? So, I mean, I tend to think of it in terms of three big questions, like, so how did this all begin? How's it all going to end? And how might things have gone differently? And so that third one is about looking for intelligent aliens, right? And in terms of if we were to find intelligent aliens, it would tell us an enormous amount about ourselves and about how contingent what our situation is relative to what else could have happened, right? So I suppose I don't really need to remind too many people of how interesting these things are, but I think it's important to remember that a lot of people have interest in those kinds of deep questions, and in many ways, the only answers to those questions can be found by having an unimpeded access to certain kinds of astronomical investigation. So we should do as much as we can to allow people to continue to do that if that is what they believe in.
You took the harder question, so I'm going to take the easiest one. And it is because there are certain things that you cannot do without space. So there are certain things like taking geographical images to fully understand what is the damages of climate change. There are certain things that cannot be collected or understood if it's not done globally, and the only way to do it is by going to outer space to take that data, to take those pictures. And it's very rough because it's, as Valerie was just saying, we need it so that we can understand, for example, climate change better. But by doing so, we're reinforcing climate change. And it's a very difficult balance to have or to do. I also found out, while reading about this, that there is a correlation in internet access and the way that certain societies develop. So if we're looking into economic and social development for countries, it is vital that they have access to all sorts of telecommunication technologies. But then how do we actually allow them to have access to those technologies where only a couple of industries or companies are the ones controlling it, is a question that is still up there. How to fully allow for adequate use of these tools and access to these tools, and not simply, well, technically you could access to internet now without actually providing that. So I think that was an easier than Jack's, but
Yes, so the research in international space law actually helps us to identify what is already there and what legal guidances we need for the future, so that we can kind of create a balance, for example, between mega constellation of satellites and other activities like space exploration and scientific kind of activities in the space. So it's really important, and I think it's a public good to identify, first of all, what legal regulations are there and what do we need to do in order to create this balance between lots of technological advancements in today's world and the science, and also indigenous kind of preservations of indigenous rights. And this is what especially the UN committee, the legal committee of the UN, I can't remember the complete.
The UN Committee on the Peaceful Uses of Outer Space.
Yeah, this is their kind of duty to identify the legal gaps, and you can add.
No, I think you did a really good job.
So the last question that I had kind of organized for discussion, and then we'll kind of throw it open to questions from you or questions from the audience, was what public good do you think might come out of this project that we did? What public good do you hope will come out of this project that we did? Same order?
I can
Different- Basil wants to go first. You take
because
it.
it's kind of
Let's mix it up. So, yeah.
yeah. Again, I think the public good that we achieved in this research was the identification of the gaps, where the legal gaps, both internationally and within Canadian law, and what could be done both ideally and realistically to create the balance that I mentioned between mega constellation of satellites and other space activities, and also kind of prevent the environmental challenges that we are facing today.
Sure. I think very related to what you were saying is knowledge and information and transmission of that information, especially for me, because I got to see very different groups of people talking about very different things. I kind of got the sense that everyone is very worried about these things for different reasons, but they think that they are the only ones worried about this thing because they don't see that they have a broader community of how this is just a major problem with several consequences. So just to give you an example, there's a group of doctors studying how the amount of light that we receive at night affect the circadian rhythms and the way that our hormones are secreted. And then we have a group of biologists here in Canada, specifically in British Columbia, studying how the amount of light affect the way that salmon are moving around in the river. And then we have a group of sociologists and anthropologists down in Australia, but also they have a connection here, especially in Alberta, studying how this is affecting the way that Inuit people are understanding the sky throughout how they not only how they connect to the sky, but how many of them resort to the sky as a source of information and how that might be affected. And then you have a lot of astronomers here talking about, hey, this is also affecting the way that we're taking pictures. And at the same time, I feel like they're not talking to each other. And I feel like that's what I take that is the most important thing. And it's, hey, this is all coming from the same thing. We should all get together and try to come up with ideas on how to solve it via legal advice, via movements, grassroots movements. I don't know, but I think that that's the most important public good.
Thanks.
Yeah, so I guess I'll just focus on my bit because you've covered kind of the larger picture very well. So the key kind of good that I think comes from trying to quantify the amount of the brightness of these satellites and the rate at which they'll be seen is that it allows you to draw quite much more precise comparisons between the trade-offs of certain kinds of decisions about how these satellites are deployed, because it's easy to say, okay, every new satellite will have an increased probability of turning up on some astronomical picture somewhere, and it's also very easy to say, okay, yes, but that satellite is also providing internet access to someone in the Congo, for example. So what you really need is to be able to is to quantitatively compare how large one of those effects is in relation to the other. And so that's what we were trying to do with this, is to give some estimation of, okay, what percentage effect is this likely to have on a particular astronomical investigation? Is it going to have a 10% kind of cut down in the amount of photographs they'll get of a good quality? And so if you know how much that program costs and you know the percentage reduction it gives you an immediate kind of metric of saying, okay, well, this is a specific cost that you are imposing on another person without doing anything about it. Is the project you're undertaking worth this cost? And if not, how can it be rectified? So that's the boring answer, right? Is the kind of providing quantitative comparison, but there it is.
Very good. Anything to add, Valerie?
No, thanks.
All right. So that's kind of our formal discussion. Is there anything that you heard in the other folks' answers that you want to add anything about, panelists? No? Okay. Do we have any questions from the audience who would like to know something about satellite constellations? Let's see. How am I going to pick? The person with the white sweater. Yes.
Thank you so much. Very interesting. I have a few practical questions, and I'm going to address each individual speaker just to provide some background. I'm not an astronomer, and I'm in information media studies and computationally inclined, but I've never studied this, just to help me fill up the gaps. Giselle, what does it take to launch a satellite, let alone satellite constellation? What are the legal hurdles that anyone, be it Musk or anybody else, would have to jump to get it up there? Sarah, what did you study? Are you talking about scientific databases, social media, news reports, law claims? What controversies are you drawing on? And Jeff, the easiest, visibility by naked eye or visibility with some kind of technology when you talk about those maps? Just help me fill in the practical things. I mean, yours is probably the easiest. You want to go on the same order?
Yeah, so
We can go.
well, so we took the raw data and then we processed it in a way where it's kind of on a unified scale. So, I mean, it's disappeared. I won't bother bringing it back. But that visual magnitude scale covers both naked eye observation and what you would see through a camera. So that's kind of an intrinsic property of just how bright the object is, and then you basically can work out where will the naked eye be able to see this? What number is attached to that? It's about 7 or 6.
So that's the line?
That's what that line is based on. Okay. But then if you then do it with a camera that's got zoom or kind of augmented in some way, that number will go to a lower brightness, right? So that the number will be higher because of how magnitude works, but you will see that at a much lower level of brightness than you would with the naked eye. So the whole line will just move down.
And that's the one you discounted, right? The one that you took, like everything below the line was not accounted for in your second run.
Yes, so that stuff below the line would still be visible with cameras and telescopes in general. Yeah.
Thank you. Makes sense.
I guess me. So it's a combination of many things. For certain groups, I only use research papers. For certain other groups, I only use newspapers, social media, especially when it was mostly community work. It was mostly newspapers and social media and blogs, a lot of blog posts about this. But also, I found that it was very interesting that these courses in between, like treaties and UN reports, not jumping into your space, but because depending on the organization who was issuing the reports, the way that they discussed it was very different. So I ended up looking into very formal, semi-formal, and non-formal at all pieces of information that sometimes contradicted each other. Sometimes they were saying, no, actually satellite constellations are just the best thing that has ever happened to us. And some of them were like, no, actually they're not. And they came from very different sources. So I tried to balance them out.
Keyword search based?
Yes.
Okay. Makes sense.
So I'm not sure if I got your question correctly, but do you mean that like the parameters for the legal parameters kind of for the redefinition of mega constellation of satellites?
More or less, like how would I launch? What do I need to apply somewhere? Like let's say I have a machine ready to launch myself.
So I
how
guess
do I
if
get it up?
Yeah, if I'm not mistaken, countries have their own national rules. And
So let's say Canada.
Let's say Canada, yeah. And there are national rules, and for example, in the laws, in the law that I mentioned, so it specifies that in order to apply, you should safeguard the space debris mitigation guidelines, for example, but the application is national and not international. But
Yeah,
Sometimes somebody approves it and says,
Yeah.
yeah,
So Canada has the remote space, remote systems, no, it's RSSA, I always forget the order of the S's, but anyway, we have this regulations, and if you have a satellite and you wanna launch it, then you have to apply to the government and you have to make sure that you submit kind of an environmental impact assessment to say this is not gonna break up in space, and also how are you going to get rid of it when it's done? So are you going to deorbit it and then burn up in the atmosphere? And if you can show all that and fill in all the paperwork, and Canada says, okay, we authorize this, then the next thing that has to happen is Canada makes a request on your behalf to the International Telecommunication Union. And when it gets to the ITU, then they're the ones that allocate to Canada, not to you, the corporation, but to Canada, an orbital slot and a radio frequency. And make sure that these don't interfere with other orbital slots and other radio frequencies. Then they communicate that back to Canada, and Canada says, okay, we requested this on your behalf, here you go. Here's your orbital slot, here's your radio frequency.
And is there enforcement involved in that too? And let's say
Well, yes, the International Telecommunication Union makes sure that there is not interference either in orbital slots or that's what they're trying to do, not interference in orbital slots or in radio frequencies. And if there are complaints, then they come back to the ITU, particularly with radio frequencies, and then they have to work them out.
So the issue that unevenness of distribution
Yes.
per country, per
Generally,
issue.
yes. Generally speaking, the International Telecommunication Union works mostly on first come, first served. They do have a certain number of slots that they keep for countries of the global south, for example, that aren't yet ready to launch satellites, but they would like to in the future. And they want to keep those slots open for them. But the rest of the slots are first come, first served, and Starlink, for example, has quite a few of those.
So it's not accidental that none of them are presented on the graph. Thank you so much.
I'm not sure I understood that question, so I think you should respond to it.
Why they're not? Do
With your Starlink thing,
you want me to get the graph?
it certainly, a big part of that is a whole lot of satellites, right?
Yeah, they have
Yeah.
8 now.
Compared, and so isn't that represented on there?
Well, I mean, the reason that Starlink has so many is because of their particular reusable rocket technology. So if other nations had, if certain other nations had that same launch capacity, their bars would probably be just as high on this graph.
They also started first.
Yeah, well, yes. So others are trying to catch up, but that's the main bottleneck, right? It's not desire, it's ability.
I don't want to, I have a, but I think you should.
No.
Get, I'm surprised that China doesn't have more satellites.
Well,
Well,
They're working on it.
yeah, they have a lot. I mean, you know, these only look small because of Starlink being so enormous, right? Which is a relatively recent phenomenon. China still has a lot. It just does not have the truly, you know, enormous capacity that Starlink has. So it's I think it's on a different graph somewhere. There's still quite a few up there. It's just it looks small on this graph.
planning many more. They're planning 2 mega constellations, and they're already starting to populate.
So that, yeah.
Black sweater.
I'm not sure if I misunderstood something there, but are you saying Starlink is the only company on this chart that has the capability of reusing their rockets that they launch in?
Yeah, well, so there's Starlink and there's SpaceX, right? So SpaceX is the only one that has kind of operational, fairly rapid reuse, right? So SpaceX launches some other satellites within the same category as Starlink, but obviously because they're both owned by Elon Musk, and I think they're probably more closely aligned than just that. SpaceX gives enormous preference to Starlink, so no other constellation would be given the kind of launch capacity by SpaceX that Starlink is. So the key answer to your question is that they have this technology where most of the cost of the rocket is recovered through reuse of the booster. So as soon as someone else develop that and people are trying, then they would, in theory, have the capacity to do the same thing.
Please.
I have two questions. The first one is more law related. I guess has there ever been historically some contention in international law, and do you see potential in the foreseeable future some issues that can come up from international law? I know international law sometimes is a joke depending on what you're studying. I study law, so that's one reason I say that. So I worry about different countries having different priorities and then there being some tension between there. And I'm not familiar with how space programs operate, so some insights on that would be fine. And then my second question is, and forgive my ignorance on this, but I know that there is some talk around how space debris can impact and create damage amongst other satellites in space, right? And then it can have a ripple effect that can impact a bunch of other satellites. So I was wondering if in that hypothetical situation that there is a ripple effect and a bunch of satellites get destroyed, does the space debris cause any visual impairment in and of itself if the lights hypothetically go out? So there's no lights anymore, but the space debris is just floating there for however long that would last. So.
Well, maybe I can take the space debris one first, and then you can think about the law one while I'm yakking. What you're describing is sometimes called the Kessler syndrome. So the idea is if my satellite runs into your satellite and then they make a bunch more pieces, those pieces are still up there moving quickly and they can run into more satellites which break into more pieces and so on. And the idea is that if your density of satellites is high enough, you can get kind of a cascading effect and then all of your satellites get destroyed. And that is not only bad for your satellites, but it's also bad even if you want to launch stuff from the surface of the Earth, right? People have talked about this as preventing future access to space.
Yeah.
Would the resulting junk in space be problematic for visual observations from the ground? I don't think so, because the pieces would be small. But I see a couple other astronomers in the room. Anybody else want to weigh in on that?
Would they do that?
They're trying to hide.
There is a thing with that where a lot of, at least with Starlink, there's a lot of intentional design going in to try and make them less bright. So if you just knocked it out in the sense that it was no longer able to control its orientation, it would immediately become much brighter because a lot of those
shiny bits would be oriented in a different way.
The kind of precise control they do to try and keep it from being bright would go wrong. If you blew it into a bunch of pieces as well, then it's more ambiguous whether it would be as bad.
And there is already pictures of junk that's already affecting the amount of light. So it's already reflecting. So even if it's all technology and the idea is not to continue to use it, that's already a problem.
Yeah, I mean, this second category is technically space junk, right? So that's already a major contributor.
On the law part,
No, you can.
if you don't mind, this major spacefaring countries are actually quite cooperative with each other. So the way that the law developed is actually through cooperation. I realize that it's fair to be cynical about some aspects of international law, especially right now. Although I would, as an international lawyer, argue that law is actually operating properly most of the time. You just don't see it in trade, in getting weather information or space information or that sort of thing. It's just on the outer edges of the wars and conflicts and such that it's not operating very well. But in space, the law itself requires cooperation, and much of that cooperation is happening. Of course, there are rivalries between China, Russia, and the United States and others, but they do share information on space situation, on space situational awareness, where are the satellites, where is the space junk, that sort of thing. And the space debris mitigation guidelines came about because of that cooperation. So I don't know if that helps to kind of place space and law and cooperation kind of on this end of the spectrum versus non-cooperation that you see here on it.
Yes, perfect.
So I have two questions. I'm going to sort of connect them at the end. The first question is, obviously anything that's orbiting Earth, it's slowly, my understanding of it is it slowly eventually comes closer to Earth, right? So we started launching satellites, I would presume in like the 70s, 80s is kind of when we started.
57,
Sorry?
1957.
Sputnik.
So it's a few years before I was born. So eventually, as everything starts coming closer to Earth, obviously you're going to have a higher density of satellites. You're going to have a higher likelihood of impact, and eventually those bodies are going to come back down to Earth. So the first question is: do we have sort of a time scale in terms of when that would happen? Is that decades off? Is it centuries off? So that's the first part. The second part is just a bit of an intersection. So I'm sort of linking this to politics. I know, like, I do a lot of activism to try and advocate for more rural regions within the NDP because it tends to be a very urban-centered party. And if I look at Starlink, for instance, right? Starlink has been sort of it's given people access to data in a way that rural and remote areas previously haven't had. Even like Oxford County, most of it doesn't have reliable cell phone data, right? And there's also, other inequities there. Like if you go to Wallaceburg, you usually have pretty good data. If you go to Bukidnon on the other side of the bridge, they don't. So typically when we're looking at government policy, it only changes when it directly affects people a lot of the time. I see trying to ban or legislate against something like Starlink to be a tough sell because of how positively it impacts a certain group of people. But then also we have these long-term effects that somewhere down the road are going to strongly negatively affect people. So how do you reconcile the immediate gains with the long-term negatives that will come from all this?
Do you want to take the orbit?
Yeah. So with the first one, so it kind of depends, right? So if you just have something that's just uncontrolled, you're right. It will eventually kind of decrease in orbit and usually re-enter. And that's that's a constant process, right? If you stand outside for more than half an hour, you'll see something come down, and there's a good chance that it is some little bit of a satellite that's burning up. So it's not so much a kind of there's some solid shell that's slowly contracting. It's more just like a constant snow of stuff that was just up there and it's kind of falling out. But with things, generally things like Starlink, for example, they have engines on them, so they will maintain a constant altitude until it's their time, and then they just drop rapidly. So the kind of timer that you're describing is less about motion between orbital shells, and it's more about just the overall density of stuff in orbit, as was mentioned, because there's theoretically a threshold where if you pass it, you will get this exponential growth in debris that would not otherwise occur.
And maybe just add that Starlink satellites last about 5 years or so.
Yeah, so they have a designed relatively short lifetime, which is not the case for all satellites. Like satellites that have been up there for 50 years. But what about the balancing of
What's the other?
rights and obligations, or who wants to talk about that?
I have a lot to say about that because I found it so interesting. How to balance out something that seems so important, like for example, internet access. I'm going to be talking about specifically internet access, but I'm really talking about many other different things. So I read a lot about the digital gap and how in many cases Starlink was mentioned as something that could help solve exactly that. The thing is, because there is no necessity for a regulation of what and where and how to control the service that they are giving, there is a fear that, first of all, there are certain things that are simply gonna be controlled by who gets to pay for what and which countries get to pay for what in which sense. So in the report for this, I included a map of who or which are the countries that right now are receiving more internet thanks to Starlink. And surprise, surprise, it's the countries that already had more internet. So the United States, Canada, Europe. And generally the global south, because they don't have a lot of paying power, they are just not receiving internet access by Starlink. So in general, globally, I'm gonna go now Canadian, but globally, because there are economic incentives, because this is just a private company, then that's not being controlled by other things. There is a question of, okay, but who gets to push them into, okay, but you promised that this was gonna be something good for the general public, but who gets to actually force them into doing so? There's a big question there. Now, specifically talking about the Canadian context, I found it especially interesting that while we were doing, in the midst of this project, Rogers signed a treaty with Starlink so that they could provide satellite internet to rural areas of Canada, and that happened July 5th or something like that. So literally middle of our project. And the main argument for that is, just as you were saying, there's so much inequality within the country on how we're accessing to this resource. The question now in Canada is now being more in terms of Indigenous communities accessing to internet and maintaining that access to internet. So there is a great discrepancy between the provinces, because there are certain provinces like British Columbia that is actively paying a Starlink so that it is cheaper for certain Indigenous communities to access to this product, but other provinces just do not have the money to do so. So, and there was a bigger question on those Indigenous communities getting together, specifically the ones in Alberta with the ones in British Columbia, asking themselves, okay, what is the use of us getting access to this if we don't know if tomorrow the province decides to just stop financing it? Are we really free in the sense of, do we actually have access to it? So globally, a question of, do we actually have more access? But also nationally, a question of, do we actually are maintaining that access accessible? I know that sounds very dumb, but I hope it's meaningful. And that is specifically related, the discussion is principally being held because of Indigenous communities now having access to internet, but not knowing if they will maintain it.
Well, and there have been cases of Starlink being turned off in certain locations.
Yeah.
Because they weren't doing whatever the president of SpaceX thought was a good idea. So,
Wow.
There is also the question of like alternatives, right? So even though currently the cheapest way to provide internet to very remote places is with Starlink, it's not technically the only way of doing it, and it would be well within the technical capacity, like, certainly within like rural, like maybe not incredibly far away, but certain rural parts of Canada, it would not be enormously difficult to provide internet by other means. So there is the question of whether all the other costs and risks associated with this globe-spanning mega constellation are worth it to do things that could be achieved in other ways, with maybe slightly more expensively. So there's not a clear answer either way, in my opinion. But yeah, there are certain things that you can only do astronomy by looking in the sky, right? You don't necessarily only have to get internet by looking at the sky. So there's that.
I just note that if there was ever a time to make a sovereignty argument, now is that time. So, to the current government, go for it.
but I mean, the question of short-term gain versus long-term potential problems is not unique to this particular situation,
That's
right?
every political issue. Every single one.
Adrian, did you have your hand up?
Yeah, I did, yeah. It got partially answered, and this is a question for Sarah mostly. So you mentioned how the global south countries are not benefiting at all from the Starlink internet service, which seems like very ironic in some sense. But even within the countries that, the wealthier countries that already have internet access, the ones who are benefiting the most from Starlink are the people, like, do the people in the rural areas of those countries, are they actually even benefiting from, are they using Starlinks, or are they not thinking about, who uses Starlink services the most?
So right now, Starlink users are going up because they now have a lot of promotion. So look at this new shiny thing. So yes, there's people actually using it. But interestingly enough, it's not mostly in rural areas. It's mostly people who live or work on boats, who do not have other options like towers. Who are mostly using Starlink. So that's like the peak of the amount of users that are interesting because they don't have other options, as Jack was saying, because it's such a niche group, but it's, yeah. But it's such an obvious group for which, which you don't have this other option. And I know that I said general, the global south is not benefiting from this, but I want to just be super clear in this. It is mainly the African continent. There are users in Latin America of Starlink, in almost every country in Latin America. There are mostly in South Asia. There are users in almost all of the countries in South Asia in which is permitted to have Starlink. It is primarily just Africa that is super underserved by Starlink right now.
And one other user of Starlink that I can point out is that the Western Meteor Physics Group that operates the cameras that we use to do this study has at least one Starlink terminal that they use to get the data back here, because it's in a rural area that doesn't have good internet.
Set up by Huron Park there, is it that?
I don't know which one it is. So. But, other questions?
Could I throw one more in?
Sure.
We've talked about public good, how about public bad? Nobody's gonna mention military at all? It wasn't on your concept map.
Yeah. So it is very interesting because all of the legal aspects from all of this started off because satellites started as a potential, the potential uses of satellites were military, were specifically surveillance, and were specifically how to target other countries. So this is where they come in, because this is where all of the outer space treaties for the safe and equal peaceful uses. That's where the peaceful comes from. I'm sure that it's not the only reason why, but it is historically the reason why. It is also the case that many of the products of it have to be public, and therefore they have to show that it's for good or for general interest. So even when they're taking pictures of different places, it's mainly, and it has to show that it is for something that anybody could use. So one of the most common examples is there is a small, actually, satellite constellation, Chinese satellite constellation that has helped a lot with Australian fires. And that has to be public access. So is the fact that they're all trying to not have anything private that has endorsed this idea that, oh yeah, we're only using it for good things. If that is legally binding enough for them not to have a secondary purpose and having something secret, I cannot say because there's no legally binding, as they just said, thing that forces you into doing absolutely nothing.
Space agencies are generally pretty decent at, so in the Outer Space Treaty, it says that the information that you learn from space, you cannot hold it yourself. You can't only use it to benefit yourself. The space agencies have been pretty good at figuring out how they're going to make that information public. But they do have very different interpretations. Like NASA will put all of the images, or many, not all, but many of the images up for everybody to use and see. And then other space agencies will give the information to academics, for example, publish papers. But there's a difference in access there, right? So how many regular public people go out and read the academic journals to get the information from some other space agencies versus they'll look at the James Webb Space Telescope images online. You know, there's a difference in really truly how freely available the information is, but they have been pretty decent at that. That said, if the information collected is military, then obviously it's classified under domestic law, and then it is not revealed.
And of course, there is lots of a long history of connection between space and things military.
Yes.
And Starlink being turned off, one example of that was Starlink being turned off over Ukraine.
Exactly the example I had in mind.
Yeah. Generally, militaries have their own, big militaries have their own satellites, and they're not relying on Starlink, but it was the case because Russia had not only done a ground war, they had done a cyber war and shut off various things, helping Ukraine, various satellites helping Ukraine. So then they had to resort to using Starlink. That said, there are militaries that do use Starlink for various specific things when they need to have a workaround. They don't always only want to rely on one satellite, for example, or a series of satellites.
There is also the issue where, because SpaceX is also launching Starshield, which is a military version of Starlink, and so what you're getting there is you're getting kind of, you know, if you think that mega constellations are a net negative, right, well then piling on military considerations is just going to give you more and more mega constellations, because not only do they want them to service commercial ends, but they want separate, you know, firewalled ones to service classified ends, and they want high amounts of redundancy in case there is some kind of massive orbital strike or war or whatever. So if your only concern is there being loads of satellites, then having the military kind of utilize this technology is just going to mean that there's way more satellites than there would be if it was just restricted to commercial purposes.
Well, on that cheerful note, maybe we should, unless there's any last questions. Dan, do you have anything to say? No?
Just thank you so much for coming.